What's up, nerds, and welcome to week 2 of Hot Nerd Summer, the challenge where we cover 9 engineering subjects in 9 weeks. Last week we introduced the fundamental theorem of calculus, which gives us the relationship between the derivative and the integral. This week we're talking about classical mechanics. The homie Isaac Newton began his studies at Trinity College at the age of 18, much like a freshman entering college today. After a couple years of hating school, he was sent home due to the plague. Sound familiar? While in quarantine, he carried out most of the work for which he is now famous, including calculus and mechanics. Mechanics is physics. Physics and calculus are like brothers, only closer. Math can be a purely theoretical framework of logic and geometry, but it can be abstracted to describe real-world phenomena. For instance, the Pythagorean theorem tells us the relationship between the sides of a right triangle given by a squared plus b squared equals c squared. We define the position vector as the arrow that points from the origin to an object as it moves in 2D space by this equation. This is a parametric equation which tells you the components of the vector and the x and y directions changing as a function of time. It happens to form a right triangle. It's easier to go along a diagonal as a shortcut than to go along the sides. Much how speed is distance over time, as in 45 miles per hour, velocity is displacement over time, a vector equation. We put a little arrow over the variable to remind ourselves that scalars have magnitude, while vectors have magnitude and direction. Last week we saw how the derivative of a function tells you the rate of change of that function. Velocity is the derivative of displacement. That means that velocity tells you how fast the ball is moving. The derivative of velocity is the derivative of the derivative of displacement. That's called acceleration, which tells you how fast something is changing its velocity. So 0 to 100 is a rap about calculus. Some call Newton the first scientist when he gave us his famous laws of motion in his publication of Principia in 1687. These laws can be used to describe mechanical systems as simple as the projectile motion of a baseball or as complex as a car engine. There are different approaches to analyzing these systems, including force balance, momentum transfer, and energy conservation. If you're looking for tips, lay out all the variables that you do know and try to play around with the math until you determine all the variables that you don't know. If you're stuck, review your math, including algebra, single variable calculus, and multivariable calculus. Physics is an amazing discipline that allows you to view the world from a unique lens. It turns the strange familiar and the familiar strange. Newton gave us both the mathematics and the framework of logic for investigating mechanics. In tandem with the progression of technology, new branches of science emerged, which gave rise to even newer technology, which led to further progression of science, and the cycle is continuing today. Although humans have influenced science, physics itself doesn't have a face, and you don't have to be a math person to study it, so make sure you sign up for Hot Nerd Summer. Finally, if you like physics and you haven't heard of Physics Girl, you're sleeping.